It's not supposed to look like this. Right now, on November 6th, 3I, Atlas, an interstellar comet fresh from another star system, has reappeared after swinging past the Sun, and it's missing something crucial. There's no tail, no radiant stream of dust and gas, no shimmering wake that defines every known comet we've ever seen. Just a bright, compact point of light, drifting alone through space. Telescopes around the world confirmed it. Even after its close solar encounter, 3I Atlas shows no visible tail. And yet, its brightness has mysteriously increased. How can an object shed energy and mass without leaving any trace? Is it breaking the rules of cometary physics or revealing something we've never witnessed before? If you're finding value in this deep dive, gently tap that like button and subscribe. Tell me in the comments where you're listening from, what time it is there, and what you think is the most compelling anomaly about 3I Atlas. Let me tell you what's happening, because what astronomers have just observed in 3I Atlas is not normal, not even by cosmic standards. After its close pass around the Sun, the third known interstellar visitor was expected to look like any other overheated comet, shedding ice, streaming dust, glowing with the telltale fan-shaped tail we've all seen in textbooks. Instead, new images showed something profoundly strange. No tail at all. Just a bright, compact point of light, glowing softly against the void a traveler stripped bare. And that discovery has shaken astronomers around the world. Because a comet without a tail isn't just rare, it's almost physically paradoxical. Near the Sun, solar radiation should vaporize ice into gas, ejecting dust and creating the very trail that defines a comet. But 3I Atlas refuses to play by those rules. Even as its brightness surged dramatically confirmed through observations from Spain, Taiwan, and Hawaii, the object remained tight and self-contained, with no discernible plume. Some even reported a subtle bluish hue, a color shift that's been seen but not yet confirmed in peer-reviewed data. For now, it's a fascinating hint, not yet proof. If that hue is real, though, it tells a story. The spectrum suggests emissions from exotic carbon compounds, diatomic carbon, and amidogen molecules that form under intense heat when ices are burned away. This would mean 3I Atlas isn't made quite like the comets we know. Its chemistry might be foreign, literally, forged under another star's light. Still, even that can't explain what's missing. Radio instruments picked up evidence of violent outgassing before perihelion, almost 40 times more water molecules per second than just weeks earlier. That kind of eruption should have produced a colossal tail, but the cameras saw none. So, where did all that material go? Some astronomers think carbon dioxide gas might have built a cooling layer that delayed dust release, creating a kind of thermal mask that cracked only briefly before sealing again. Others suspect something deeper, that 3I Atlas's interior isn't a typical mix of ice and rock at all, but a denser, metal-rich body, shedding gas invisibly rather than scattering dust. And if that's true, it means this visitor isn't just strange, it's rewriting what we thought a comet could be. But the mystery doesn't end there. Because if 3I Atlas can defy the physics of every comet we've studied, what does that say about the place it came from? The most recent images confirm it. Even now, weeks after perihelion, 3I Atlas remains eerily intact, still bright, still compact, and still missing the one feature that defines a comet: no tail. Telescopes in Chile, Spain, and Hawaii all reported the same thing: a condensed, glowing nucleus that refuses to release a dust plume. The data from SOHO and Stereo A, the solar observatories that monitor objects near the Sun, back this up. Their coronagraphs caught 3I Atlas moving through the inner solar system as a faint, elongated light, but with no trace of a tail behind it. That's the confirmed part. The question is why? Astronomers reviewing photometric data noticed that the comet's brightness didn't fade after its solar encounter, it actually increased. That suggests active outgassing, some process still feeding the glow. But without a dust tail, the material escaping must be finer, more volatile, possibly pure gas rather than solid particles. And that leads back to the mystery of its color. Observers continue to note a slight blue tint, though it remains unverified by formal spectroscopy. If real, it could mean the object's surface is rich in carbon compounds or cyanide radicals, materials that emit blue light when excited by solar radiation. But so far, these reports are observational, not peer-reviewed. Scientists are careful to say, it's a pattern, not yet a conclusion. Still, it fits the pattern of something deeper, that 3I, Atlas, might be composed of highly volatile ices, the kind that evaporate too quickly to create a long-lasting tail. Instead of forming a visible dust trail, these gases could be dispersing invisibly, giving the illusion of a naked comet. Yet even that explanation doesn't settle everything. The rate of its brightening, the unusual stability of its shape, and the lack of debris don't fully add up. If material was being ejected, instruments like NEOEYES or even ground-based telescopes should have caught dust scatter by now. They haven't. This is where the story shifts, from confirmed observation to emerging theory. Some researchers believe the comet's outer layers may have compacted into a hardened crust, a thin, carbonized shell that prevents dust escape. Others think 3I, Atlas, is venting through tiny fissures, releasing jets so fine that the tail dissipates faster than our instruments can detect. Whatever the mechanism, one thing is clear. This object isn't following the same rules as comets born in our solar system, and that alone makes it invaluable, because with every new observation, we're being forced to rethink what cometary activity even means for interstellar bodies. And the latest light curve data hints that this phase, this strange, tailless brilliance, may not last much longer. Its brightening has begun to slow. If that trend continues, 3I, Atlas could soon dim again, fading into the deep, taking its unanswered questions with it. But before it disappears, astronomers are racing to capture every bit of data they can. Spectral signatures, infrared heat readings, even polarimetrics scattering anything that might reveal what's happening beneath its crust. Because buried within those readings could be the key to understanding not just Atlas, but the chemistry of the stars it came from. And that's the heart of it. This isn't just a comet mystery anymore. It's a message from another solar system, one written in light, color, and silence. So what happens next? Will Atlas fade quietly into the dark? Or could this be the calm before another outburst? A final flare revealing what it truly is? Either way, the telescopes are still watching, and the story of 3I, Atlas, is far from over. In the newest reports, that silence in the data, that strange lack of a tail, is becoming even more intriguing. On November 5th, updated measurements from the Naves Observatory and the Lulin team confirmed that 3I, Atlas's brightness curve, has plateaued. The object hasn't faded the way normal comets do after perihelion. It's holding steady, pulsing faintly, as if balanced between activity and exhaustion. That steady glow is what has astronomers scratching their heads. If it were a typical comet, its brightness would drop sharply after releasing its volatile ices near the Sunday. But 3I, Atlas, isn't behaving like a body that's cooling off. It's as though something beneath its surface is still releasing energy, a process that doesn't fit the textbook definition of sublimation. Some teams propose that its subsurface could be layered, a hardened crust on top, insulating pockets of trapped gas underneath. Every so often, pressure could build just enough to release a burst of gas, keeping the comet luminous even without a visible tail. It's a plausible explanation, but so far, only theoretical. Other researchers are exploring more exotic ideas. If 3I, Atlas, formed in a region rich in carbon monoxide or methane ice, then its surface chemistry might be completely foreign to our models. These compounds sublimate at far lower temperatures and could vent energy differently, glowing brightly, without forming the dust streams we're used to seeing. That kind of behavior would make 3I, Atlas, not a failed comet, but an entirely new category of interstellar object. The fact that this object has stayed so cohesive, with no visible fragmentation, even after intense solar heating, adds to the mystery. Most comets that approach this close to the Sun begin to break apart. 3I, Atlas hasn't. Its structure seems strangely resilient, as though bound by materials stronger than the porous ice and dust that make up local comets. These clues know tail, sustained brightness, structural integrity together, paint a picture of a body that's not behaving under our rules. And for scientists, that's both exciting and unsettling, because if this is what interstellar comets are truly like, It could mean our understanding of how planets and minor bodies form in other systems is incomplete. Perhaps we've been looking at only one version of cosmic chemistry, the one that happened to evolve around our Sunday. Meanwhile, astronomers are continuing to observe 3I, Atlas, with everything they have from ground-based spectrographs to the Hubble and even the James Webb Space Telescope, each trying to capture one more data point before the object drifts too far into the darkness. For now, it remains just bright enough to study, and that small window of time is precious. Each night of observation could bring the next surprise, a shift in spectrum, a flicker of polarization, a hint of dust that might finally reveal what's really happening. Because 3I, Atlas has already rewritten one rule of cometary physics. The question now is, how many more will it break before it's gone for good? As the latest datasets come in, the picture of 3I, Atlas becomes clearer in some ways and even more confounding in others. In early November, astronomers comparing data from different observatories noticed subtle fluctuations in its light curve, almost like faint pulses. Not random noise, but rhythmic enough to draw attention. Some interpret these as rotational signatures, meaning 3I, Atlas might be spinning faster than we thought. A fast rotation could cause jets to fire unevenly or prevent material from forming a stable tail. If that's true, then the missing tail may not mean inactivity at all, it could mean instability. Imagine an icy core spinning so quickly that gas bursts are flung off in unpredictable directions, dispersing before they can align into a visible trail. For a brief moment after perihelion, those jets could have balanced each other out, leaving a glowing core but no defined tail. It's a fascinating idea, though still speculative. The light curve, variations are real, that's confirmed, but their interpretation remains open. Some researchers urge caution, pointing out that instrumental differences or scattered sunlight could mimic such effects. Others are less convinced this is coincidence. The pattern, they argue, is too consistent across multiple telescopes to ignore. Meanwhile, compositional modeling continues. Using data from both optical and infrared wavelengths, scientists are attempting to reconstruct what 3I, Atlas, is made of. Preliminary fits suggest a mix rich in carbon and nitrogen compounds, similar to the interstellar comet. Borisov, yet denser and more stable. It might be a kind of carbon glass, hardened through countless eons drifting between stars. That hardened surface could be what protected it during its close solar pass, sealing volatile gases inside, only allowing a slow, controlled release afterward. In that scenario, 3I, Atlas wouldn't be a dying comet at all, but a survivor, a fossil from another planetary system that just happens to be passing through ours. If so, its silence, that lack of a tail, becomes poetic. It's not what it's showing us, but what it's hiding that matters. The scientific community is cautious. Peer-reviewed studies are underway, and as of now, no single explanation accounts for all of the observations. But one thing is certain: 3I Atlas is now the most puzzling interstellar object since Oumuamua. And just like Oumuamua, it's stirring questions that cut to the heart of planetary science itself. How do worlds form under different suns? What materials bind them together? And could objects like this be common, quiet, tailless travelers that pass through the galaxy unnoticed? Each night that astronomers point their telescopes at this fading visitor, they're not just watching a comet, they're watching a messenger, a fragment from another sun's nursery, whispering across light years that the universe still has secrets it refuses to give up easily. Soon, 3I, Atlas, will slip beyond our reach again, heading back into interstellar space. When it does, it will take those secrets with it, perhaps to drift for another billion years before being caught in the light of another star. But before that moment comes, we still have time, a few weeks, maybe to gather what we can, to read what little remains written in its light. Because when the last observation is logged, and 3I, Atlas, finally fades from our instruments, one question will linger longer than any image. Did we just witness an alien comet, or something entirely new? The more astronomers look, the more 3I, Atlas, seems to resist every label we try to place on it. Even now, fresh spectral analyses are revealing tiny discrepancies, hints that its light isn't scattering the way a comet's normally would. The polarization of that light, how it vibrates as it travels through space, appears smoother, and more uniform than expected. It's as if the particles around the object are smaller, or fewer, than those surrounding ordinary comets. That detail, though subtle, could be the key. Smaller dust grains would disperse too quickly to form a lasting tail. They'd fade into the solar wind within hours, invisible to most instruments. In that case, the missing tail isn't missing at all. It's simply too fine, too faint, too fast to see. But even that explanation leaves questions. Why would an interstellar comet release only microscopic dust? Why not larger fragments, as all others do when heated by the sun? Some researchers suspect that 3I, Atlas might have undergone a transformation long before it entered our system, perhaps through radiation exposure during its interstellar journey. Over millions of years, cosmic rays could have eroded its surface, compacting it into a fine, carbon-rich crust that only allows vaporized gases to escape. When sunlight hit that hardened exterior, the volatile gases beneath could vent through microscopic pores, releasing light but no visible dust. That, at least, would explain the strange combination of high brightness, blue tint, and tailless profile all at once. It's a delicate theory, but one that matches what we see: an interstellar body carrying the scars of deep time. And in that realization lies something profound. Every observation we make of 3I, Atlas, isn't just about one object. It's a glimpse into chemistry that evolved under another sun, a frozen relic from a solar system we may never find. Its carbon ratios, its volatile composition, even its reaction to our star's heat, all are clues to how different the universe can be, and how much of it we've yet to understand. Already, astrophysicists are preparing papers for publication, comparing these findings with models from Borisov and Oumuamua. The early consensus? There may be no single type of interstellar comet. Each one could represent a different planetary system, a different history, a different origin story. And that's what makes 3I, Atlas, so precious. It's not just a traveler, it's a sample of another world, one that we can only study while it drifts silently past. Soon, it will fade into the cold beyond Neptune's orbit, growing dimmer with each passing night until it vanishes entirely from view. But even as it disappears, the data it leaves behind, those faint spectral lines and light curves, will continue to echo. Scientists will analyze them for years, refining models, comparing them to other future interstellar visitors. Because if 3I, Atlas, has taught us anything, it's that the universe isn't predictable. It's creative. It writes its own rules, and every so often, one of its messengers crosses our sky, not to answer our questions, but to remind us how little we truly know. The light of 3I, Atlas, is still visible, for now, just a dim, unwavering glow. But in that fragile light, drifting between stars, lies the most extraordinary message of all. The universe is still full of strangers. As the weeks pass and the comet drifts farther from the sun, the latest updates continue to trickle in, faint, delayed signals from telescopes tracking its retreat. The reports are quieter now, but each one still adds a small piece to the puzzle. The James Webb Space Telescope, operating in infrared, has begun analyzing residual heat signatures from 3I, Atlas's surface. Early interpretations suggest the object may be cooling far more slowly than expected. That's strange because a typical comet, stripped of its volatile ices, should dim quickly once it leaves the sun's influence. But 3I, Atlas, still glows with a faint thermal afterimage. It's as if something beneath its crust continues to radiate warmth. Maybe trapped gases are still venting in slow bursts. Maybe sunlight absorbed deep within the surface is bleeding back out. Or maybe, as some quietly speculate, its materials are denser, richer in carbon or metal, capable of retaining heat longer than anything in our solar system. No one knows for sure yet, but this unexpected thermal persistence means scientists can keep observing it longer. The precious extra weeks to gather the last spectral readings before it fades entirely into the black. Meanwhile, the debate around its missing tail continues to evolve. A few astronomers now argue that the term missing might not even apply. They suggest that the tail of 3I, Atlas, could simply be made of particles so faint and so short-lived that even our most sensitive cameras can't pick them up. In their view, what we're seeing is not the absence of a tail, but the boundary of our own detection limits. And there's a quiet humility in that idea. Sometimes, the universe doesn't defy our physics, it just exceeds our instruments. But there's another interpretation, one that's more philosophical than technical, and it's starting to take hold among the researchers who've spent months watching this visitor. They see 3I, Atlas not as a puzzle to be solved, but as a messenger. A traveller from another sun, passing briefly through our sky, revealing just enough to make us question our assumptions about the cosmos. Every frame of data, every spectral line, every whisper of light from this object has already deepened our understanding of what's possible. It's shown us that even the simplest question, why doesn't it have a tail, can open a doorway to whole new ways of thinking about chemistry, physics, and the birth of worlds. Soon, 3I, Atlas, will vanish from even our most powerful telescopes. Its signal will fade beneath the background noise of stars, but the mystery it leaves behind will linger, a challenge written in motion, a cosmic riddle that will push the next generation of astronomers to build sharper instruments, faster algorithms, better eyes on the sky, because somewhere out there, beyond the edge of the solar wind, more travelers like Atlas are moving between the stars. Some may look like comets, some may not, but each one carries a fragment of a story far older than ours. The story of how matter moves, changes, and endures across the endless dark. And perhaps one night, another such object will appear, another anomaly, another unexpected visitor. And when it does, we'll be ready not just with better telescopes, but with the memory of 3I, Atlas, the comet that came from the stars and refused to be what we expected. Because that's the truth of discovery. The universe doesn't always answer in the ways we hope. Sometimes it simply holds up a mirror and reminds us how much wonder we still have left to learn. In the days that follow, the updates begin to slow. The comet, if we can still call it that, is dimming, its light stretching thin as it moves beyond the reach of most amateur telescopes. Only the largest observatories can still pick it out from the noise, a faint shimmer against the infinite black. What's remarkable is how calm that fading is. No sudden fragmentation events. No collapse in brightness. 3I, Atlas simply drifts, quietly, steadily, as though nothing in its nature was ever fragile. Astronomers at the European Southern Observatory note that its residual glow is unusually smooth, lacking the kind of flickering that would suggest tumbling or spinning debris. It's not breaking apart. It's leaving, intact. That alone is enough to make researchers pause, because this means 3I, Atlas, survived one of the most intense environments imaginable, the sun's furnace, and emerged whole. Even without a tail, without visible dust, it remains a coherent body. That resilience tells us something profound about its makeup. Whatever it's made of, it's stronger, more tightly bound than most comets we've ever studied, and that realization turns 3I, Atlas, from a curiosity into a clue, a window into how differently nature might build things in other corners of the galaxy. When Oumuamua passed through in 2017, it puzzled us because of its shape and acceleration. When Borisov arrived in 2019, it astonished us with its familiar cometary behavior. But 3I, Atlas, feels like a bridge between the two, both familiar and alien. It shines like a comet, moves like an asteroid, and behaves like neither. Each of these interstellar visitors adds a new brushstroke to the cosmic portrait we're building, one where not all comets are icy, not all asteroids are rocky, and not all rules are universal. As it slips beyond Mars's orbit now, scientists are finalizing their last reports. The final brightness logs, the final spectral calibrations, the last polarimetric measurements. When those are done, 3I, Atlas, will officially join the archives, a coded line of data, a distant point of light frozen in record. But for those who followed it night after night, it's more than data. It's a feeling, the awareness that, for a brief time, something from another star passed through our sky. It arrived unannounced, broke the patterns we knew, and then disappeared, leaving behind questions no one expected to ask. And maybe that's the real purpose of visitors like this. Not to deliver answers, but to remind us that the cosmos is larger, stranger, and more creative than our models can contain. 3I, Atlas is gone now, almost invisible to our eyes. But in its fading light lies a quiet truth. We are still in the early days of understanding the universe. Each time we think we've mapped its boundaries, something drifts in from the dark to prove we haven't. Somewhere out there, another interstellar traveler is already on its way, cold, silent, and waiting to be seen. And when it finally arrives, it will find us here still watching, still wondering, still listening to the stories carried by the light of passing stars. Soon, even the last observatories tracking 3I, Atlas will lose sight of it entirely. Its position will blend into the deep background, its trajectory stretching outward toward the edges of the Oort cloud, and then, eventually, beyond. From there, it will drift for tens of thousands of years before passing near another star, perhaps to repeat this story again, unannounced and unexplained. But what it leaves behind on Earth is already transforming astronomy. Teams at the Minor Planet Center and NASA's Center for Near-Earth Object Studies are updating how they classify interstellar visitors. Instead of assuming that all incoming hyperbolic objects will behave like comets, they're preparing for a spectrum of behaviors: tailless, volatile, poor, metallic, or even hollow bodies that resist easy categorization. 3I. Atlas forced that change. Data scientists are also rethinking how to identify these visitors earlier. Machine learning systems that once filtered out non-tail objects as likely asteroids are being retrained, because now a tailless profile doesn't mean ordinary, it might mean extraordinary. And yet, beyond the technical lessons, there's something deeper taking hold among astronomers, a kind of quiet awe. For months, they watched a fragment from another solar system glide past our own, spinning slowly, reflecting sunlight older than humanity. They debated its chemistry, modeled its heat, and chased its light until it faded. And when it finally slipped away, what lingered wasn't just data, but gratitude. Because for all our technology, there's still something profoundly human about looking at the unknown and trying to understand it. Each graph, each light curve, each coded line of observation represents an ancient instinct, curiosity turned into science. 3I. Atlas reminded us why that instinct matters. In a universe of noise, it was a brief, clear signal proof that the cosmos is not empty, but connected. That even across the vast, cold distances between stars, the echoes of other worlds can still reach us. And maybe that's the real discovery here. Not just that an interstellar comet can exist without a tail, or that its chemistry might be unlike anything we've seen before, but that the boundaries between solar systems aren't as rigid as we once believed. Matter moves, light travels, stories cross the dark. Long after its last photons vanish, the questions 3I Atlas raised will remain questions about how worlds form, how they survive, and how many more are waiting in the endless night, unseen but on their way. The next interstellar visitor might already be coming. It could appear tomorrow, or in 1,000 years. But whenever it does, we'll be ready wiser, humbler, and still listening. Because 3I, Atlas taught us something no telescope could ever measure. That in the silence between stars, even a single fading light can change the way we see the universe forever. Somewhere, in the quiet corners of astronomy forums and late-night research meetings, the story of 3I Atlas hasn't ended. Now that the data has slowed, what remains are the interpretations, the theories, the speculations, the possibilities that reach beyond what the evidence alone can say. Most scientists are cautious. They remind us that much of what 3I Atlas did, its strange acceleration, its rapid brightening, even its blue hue can likely be explained by the ordinary physics of comets behaving under extraordinary conditions. Outgassing, uneven surface venting, or sunlight reflecting off newly exposed ice. These remain the leading candidates. In that light, 3I Atlas could simply be a fragile remnant of another system, breaking apart under the stresses of its first close pass around a star in millions of years. But there are others who lean toward the unknown. The subtle non-gravitational acceleration and lack of visible jets echo too closely, they say, the behavior of one I Oumuamua. The similarities are hard to ignore, both small, both tumbling, both showing motion that light pressure alone could explain. This has led to a controversial but persistent speculation that some interstellar objects might not be natural at all. It's a claim that divides the community. Harvard astronomer Avi Loeb has argued that 3I Atlas, like Oumuamua before it, could be a fragment of alien technology, perhaps a thin, reflective shard of something once engineered, drifting through the galaxy as debris of a civilization long extinct. His hypothesis is bold, and critics argue it stretches beyond the data. Still, it resonates, not because it's proven, but because it reminds us that the universe doesn't owe us simplicity. Others offer subtler versions of the same idea. What if interstellar objects like 3I Atlas are not spacecraft, but technosignatures, artifacts created accidentally by intelligent processes, shattered satellites, discarded sails, or the remains of interplanetary industry? After all, humans have already launched enough material into space to ensure our own fragments will drift between stars one day. If we can seed the galaxy with debris, perhaps others already have. Of course, there's no evidence of this, no radio emissions, no repeating patterns, no engineered geometry we can resolve. But it's a thought that lingers, one that sits between physics and philosophy, that maybe these visitors aren't just wanderers, but messengers of time, proof that the story of intelligence in the universe might be broader than we can yet measure. Still, the more sober voices of science remind us that nature, too, can build things that seem designed. A flat shard of rock, sculpted by heat and rotation, can mimic a sail. Gas venting from fractures can create steady acceleration. Light itself, striking the right mineral, can shift a color toward blue. The universe has had billions of years to perfect illusions of intent. And so, the debate continues not between believers and skeptics, but between two kinds of wonder. One, grounded in physics, and one that reaches just beyond it. Because when you strip away the theories and the noise, one truth remains. 3I Atlas was real. It came from another star. It acted in ways that challenged what we thought we knew. And maybe that's enough. The speculation surrounding 3I Atlas has taken on a life of its own. It now drifts through the scientific community, much like the comet itself, once did quiet at first, but steadily gathering gravity as it moves. In conference rooms, online forums, and quiet observatories where night stretches endlessly, one question keeps resurfacing. What really was 3I Atlas? Was it simply a comet, an icy relic from another system, behaving oddly because we've never seen one quite like it? Or was it something more, something built, not born? No one truly knows. But as the object fades into darkness, the debate only grows louder. Among the majority of astronomers, the consensus remains cautious and disciplined. They remind us that every mystery of the cosmos, every unexplained anomaly, eventually yields to physics. Even when data doesn't fit the model simply expands. 3I Atlas, by their estimation, could be behaving exactly as a fragile interstellar body should when exposed to our sun for the first time. It may have fractured internally, venting gases in patterns invisible to our instruments. The geometry of those fractures, perhaps angled just right, could have created the illusion of a smooth acceleration, consistent but faint. Its bluish tint, they say, might have been nothing more exotic than ionized carbon monoxide glowing under solar radiation, or a reflection of newly exposed crystalline ice. As it lost mass and dust, its coma would have grown clearer, scattering shorter wavelengths and leaving that cool hue behind. To these scientists, the story of 3I Atlas is a triumph of natural wonder, a demonstration that the universe still holds forms and materials beyond our current understanding, but not beyond nature's laws. They point to the immense diversity of comets we've already studied, those that split in half, those that vaporize without warning, those that refuse to behave according to pattern. 3I Atlas may simply belong to that unruly family of cosmic drifters, beautiful, unpredictable, but entirely natural. And yet, not everyone is satisfied with that explanation. In the margins of scientific discourse, where curiosity dares to tread into the speculative, a different story is being told. A small but vocal group of theorists argues that the behavior of 3I Atlas, especially its sustained acceleration and possible compositional anomalies, hints at something the natural model struggles to fully explain. They're not claiming proof of alien technology, but they refuse to ignore the similarities between 3I Atlas and its predecessor, 1I Oumuamua. Both objects accelerated beyond gravitational expectations. Both showed no visible outgassing or jets. Both displayed unusual reflective properties and non-standard light curves. Coincidence? Possibly. But perhaps coincidence, in the vast timescale of the cosmos, is just the name we give to patterns we haven't yet deciphered. Dr. Avi Loeb, known for his provocative stance, has framed this question not as belief, but as risk management. If even one of these objects were artificial, the implications for humanity would be profound. He doesn't say that 3I Atlas is engineered, only that the possibility should not be dismissed out of fear of ridicule. His critics argue that extraordinary claims require extraordinary evidence, and so far, none exists. But Loeb's point is less about proof and more about perspective. He challenges us to expand the boundaries of what we consider plausible. Because if life emerged on one planet around an average star, in an average galaxy, in an average epoch of cosmic history, then why not elsewhere? And if civilizations arise, why wouldn't some of them explore, build, and leave artifacts behind, fragments of their curiosity scattered like pollen through the galaxy? It's a romantic idea, one that ignites public imagination far beyond academic halls. Perhaps that's why stories of 3I Atlas have escaped scientific journals and found their way into documentaries, art, and even quiet philosophical essays about cosmic solitude. Because even without proof, the image of an interstellar messenger, a shard of something alien passing silently through our sky, touches something deep within us. Still, between the poles of skepticism and speculation lies a quieter truth. We simply don't have enough data. When 3I Atlas appeared, humanity was lucky but not ready. The discovery came late in its trajectory, giving astronomers only a brief window to study it. By the time it brightened and shifted color, it was already on its way out. That's why, in the wake of 3I Atlas, space agencies are changing how they think about the next visitor. The upcoming Vera C. Rubin Observatory in Chile, set to begin its legacy survey of space and time, LSST, will scan the entire southern sky every few nights. With its massive field of view, it could detect interstellar objects months, even years, before they reach perihelion. That means more time to prepare, more time to point telescopes, more time to ask questions before the light fades. And beyond Earth, a new generation of missions is being planned. NASA's Comet Interceptor mission, scheduled to launch later this decade, is designed precisely for moments like this. It will wait in space, poised to intercept the next unexpected visitor. If fortune favors us, it might be 4I, the next interstellar body to cross our path. Scientists hope to capture not just images, but particles themselves, samples of matter that formed around another star. Imagine that, holding in our hands dust older than the Sunday, atoms forged in the heart of a different system, older than our species, older than our oceans, drifting through space for eons, only to be caught by our instruments at last. Whether 3I Atlas was natural or not, its legacy is clear. It has changed how we look for company in the stars. Of course, there are deeper, quieter speculations too, the kind that live in thought experiments rather than research papers. What if 3I Atlas wasn't an accident of timing, but part of a broader pattern? Some astrophysicists have toyed with the idea that the Milky Way could be laced with interstellar highways, pathways of gravitational slingshots, where debris from countless systems passes through in predictable currents. Our solar system might just lie along one of these galactic routes. If true, then objects like 1I Oumuamua, 2I Borisov, and 3I Atlas are not rare, they're inevitable. Every few years, a new traveler might arrive, each bringing a different clue about the chemistry and chaos of its origin. And if any of them were engineered even one, it would mean that we are already part of someone else's map. There's no evidence for that yet, only imagination. But speculation is where discovery begins. It's the seed of hypothesis, the spark before the data. And perhaps that's the quiet message of 3I Atlas, that even when the facts are uncertain, curiosity itself becomes a form of exploration. Because whether it was a comet, a fragment, or a relic of something greater, 3I Atlas, did what no machine or mission ever could. It reminded us that we are not the center of the story. Somewhere out there, other systems are throwing their pieces into the dark too. Some are lost forever, some collide and burn, and a lucky few, pass close enough to be seen. And in those brief moments, under the dome of our own fragile sky, we realize that the universe is not a gallery of distant lights, but a living network of travelers, connected by motion and time. 3I Atlas may have been natural, it may have been mechanical, or it may have been something in between, a messenger shaped by forces we don't yet understand. But either way, it left behind a question no telescope can answer. Who else is out there, watching their own visitor drift by, wondering if it came from us? The scientists who track 3I Atlas know something the rest of us are only beginning to understand, that it won't be the last. Our solar system is not an isolated island, but an intersection, a crossroads through which the debris of other worlds quietly drifts. And as our eyes grow sharper and our instruments faster, we will see them coming. The question is, what happens when one arrives that doesn't behave like anything we've ever known? Imagine this. It's the early 2032. The Vera C. Rubin Observatory has been running for several years, scanning the southern sky every 2 nights. On an otherwise uneventful morning, a research assistant at the Chilean facility notices a faint object, fast, dim, and moving against the background stars in a way that catches the algorithm's attention. Within hours, its orbit is computed, and the message spreads like wildfire through the astronomy community. Hyperbolic trajectory, high velocity, inbound from the direction of Cygnus, another interstellar visitor, 1-4I, the next of its kind. At first, the excitement feels familiar. Telescopes pivot, data floods in. The same ritual begins: observation, analysis, debate. But this time, something is different. The brightness isn't consistent. The object flickers, not randomly, but rhythmically, in a way that no cometary rotation model can quite explain. Its color shifts too, subtly, over time, first a cold grey, then faint amber, then pale green. Some call it noise, others call it modulation, a signal encoded in light. It's probably nothing, they say, an observational artifact, the result of spin and sunlight glancing across irregular surfaces. But as days pass, and as spectral data comes in from Webb and the European Extremely Large Telescope, the patterns remain stubbornly regular. And so begins the debate that has haunted the scientific world since Oumuamua and 3I Atlas, only now, it's not hypothetical. Could this be something artificial? Not a ship, perhaps. Not an alien probe in the cinematic sense. But maybe a fragment of something once built a sail, a reflector, a broken plate, drifting through the interstellar medium. The thought is almost unbearable in its implications. Not because it proves we're not alone, but because it forces us to face what being not alone really means. Would we try to intercept it? NASA and ESA already have plans sitting in simulation folders, concepts for rapid response interceptors, craft designed to launch within months of a detection. The Comet interceptor mission will be the first, but future iterations could be faster, capable of slingshotting from Earth orbit to meet an inbound object before it escapes. If 4I ever appeared, and its properties truly defied natural explanation, humanity would face its most delicate scientific question yet: how to study something that might not want to be studied. Would we treat it like a comet, chart its orbit, collect dust, measure, spectra, or like a relic, something sacred? History suggests both. Some scientists would insist on restraint to observe, not interfere. Others would argue that the window of opportunity would be too precious to waste. And the public would ignite with fascination and fear in equal measure. Conspiracy channels would explode. Philosophers would debate whether contacting it meant contacting them. News networks would fill their banners with cautious language. Unidentified interstellar object displays unexplained regularity. And through it all, telescopes would watch. Every fluctuation, every reflection, every fragment of light analyzed for meaning. It's easy to imagine this as science fiction, but the truth is, we're only one detection away from this becoming real. If the next interstellar object displays signs that are even slightly non-random, if its shape suggests geometry, if its motion follows harmonic rather than chaotic patterns, if its spectrum contains a repeating emission that doesn't fit natural chemistry, then the conversation changes forever. For the first time, we would have to consider that contact doesn't always come in the form of communication. Sometimes, it comes as evidence mute, drifting, indifferent, but undeniable. And yet, even then, there's a kind of humility woven into the thought, because maybe